Today marks the start of collision implementation. Specifically, we're going to be going over sphere-sphere collision. At its core, sphere-on-sphere collision is checked by taking the distance between them and adding their radii together. This is fine for two spheres, but imagine we had 200.
How about 2,000,000?
No, 1,000,000.
This results in a ton of unnecessary calculations that can be avoided with one simple trick.
World space partitioning.
The idea is that we shouldn't be wasting time calculating if two objects are colliding if they're kilometers away from each other. What I ended up implementing was a class that defined a set of chunks with a dictionary using their position as the key. I could then check if a position was inside the chunk by dividing the position by the chunk size, flooring it, and scaling it back up again. If an object is outside of the chunk, it's marked for reassignment by adding it to a concurrent bag. A concurrent bag is basically just a list where the order doesn't matter, and it's also thread safe, which helps for the future. Once all the chunks are updated, simply reassign all of the orphaned objects to their corresponding chunk. To save a repeat calculation, I also store the floored position from earlier inside the bag, which is always identical to the key used for the chunk. All that's left to do is to check for empty chunks and remove them. Once the chunks actually know what objects are inside them, we can finally call for the physics update. Now that we're only checking for objects relatively close together, we avoid those unnecessary calculations mentioned earlier. Here's 40 spheres being updated every game tick, running at an average 300 frames per second. I think for now this works, but when it comes time implementing half space in plane collisions, it might get a little costly.